Think a wooden house burns down instantly or rots in the British weather? Modern engineering proves the exact opposite. In fact, right now, structural engineers are using advanced timber technology to build structures that are stronger than steel, more fire-resistant than concrete, and engineered to last for centuries. The traditional construction industry has been hiding a massive truth from you, and it all starts with a molecular breakthrough. For decades, the UK and European housing markets have been trapped in a rigid mindset that safety requires brick and strength demands concrete. But while traditional masonry buildings suffer from structural cracking, damp penetration, and skyrocketing heating costs, a quiet revolution is happening in off-site automated factories. Today, we are breaking down the 5 high-tech wood engineering marvels that make traditional building materials look completely obsolete. And wait until you see number 1. It completely flips everything you think you know about structural fire safety. Let's address the biggest fear of any UK homebuyer first: moisture, rot, and the relentless British rain. Traditional softwoods act like sponges, absorbing water, expanding, and eventually decaying. But modern engineering has solved this at a molecular level through a process called acetylation. By altering the wood's chemical structure using an organic compound, engineers permanently change the free hydroxyl groups into acetyl groups. In plain English, the wood is chemically altered, so it physically cannot absorb water anymore. It loses its appetite for moisture. The structural capability here is staggering. Modified woods like Akoya deliver a gold standard Class 1 durability rating. We are talking about a timber product that comes with a 50-year warranty above ground and a 25-year warranty directly submerged in water or soil. It will not warp, it will not twist, and insects won't touch it because they don't recognize the modified carbon bonds as food. Look at real-world applications across European coastal projects and premium UK self-builds, where traditional brickwork suffers from frost damage and spalling, and where steel rusts under salty sea air, acetylated timber remains perfectly stable. It makes concrete look overrated because it eliminates the need for toxic chemical preservatives, reducing maintenance costs to absolute zero while locking away carbon for a century. But what about sheer structural scale? You can't build a multi-story urban apartment complex out of standard timber framing without hitting massive structural limits. Or can you? Enter Cross-Laminated Timber, or CLT. The engineering breakthrough behind CLT is deceptively simple but incredibly powerful. Perpendicular orientation. Layers of solid kiln-dried timber are stacked on top of each other at alternating 90-degree angles, then bonded under immense hydraulic pressure using high-strength, non-toxic structural adhesives. This creates an engineered panel with multi-directional tensile and compressive strength. Weight for weight, CLT possesses a higher load-bearing capacity than structural concrete, but it weighs up to 80% less. This means foundations can be downsized, radically lowering ground engineering costs. In London, projects like the Dalston Works stand as massive testaments to this tech, utilizing CLT to construct high-density, multi-story buildings on sites where traditional concrete would be far too heavy to support over subterranean transport tunnels. While a concrete frame requires weeks of pouring, setting, and curing, pre-cut CLT panels are crane-assembled on-site in a matter of days with millimeter precision, saving developers hundreds of thousands in on-site labor and interest fees. If CLT is the ideal choice for solid, high-strength walls and floors, what happens when an architect wants to create massive, sweeping, open-plan spaces without a single intrusive support column? That is where Glulam takes over the structural skeleton. Unlike CLT, Glulam consists of multiple layers of wood laminations running parallel to the length of the member. This specific engineering alignment allows it to be manufactured into incredibly long spans and dramatic, curved geometries that would be physically impossible or prohibitively expensive to replicate in steel or concrete. The structural benefit here is immense design freedom paired with extreme structural integrity. Glulam beams can easily span over 100 meters without intermediate supports. This makes it the ultimate premium material for grand, eco-aspirational self-builds and iconic public infrastructure across the UK and Europe. When comparing this to a standard steel universal beam, steel will deflect and distort under extreme thermal changes, requiring expensive cosmetic cladding to hide the cold industrial look. Glulam provides structural dominance while serving as its own stunning, exposed interior finish, bringing premium craftsmanship directly into the architectural DNA of the home. But this is where wood does something structural steel never could. Most people assume that in a catastrophic fire, a metal structure is your safest bet. But that assumption is a dangerous architectural myth. In the next 60 seconds, you're going to see exactly why structural engineers actually prefer heavy timber over steel when the stakes are at their absolute highest. Let's tackle the ultimate myth: fire resistance. The general public looks at a thumbnail that reads fireproof and assumes it's clickbait. It isn't. Mass timber engineering relies on a highly predictable natural defense mechanism known as controlled charring. When solid mass timber, like a large glulam or CLT column, is exposed to fire, the outer layer chars at a highly predictable rate, roughly 0.65 millimeters per minute. This charred outer layer acts as a dense, highly effective insulating blanket. Because wood is an exceptionally poor conductor of heat, the char layer completely seals off the inner load-bearing core from oxygen and intense heat. Now compare this to structural steel and concrete. At around 500 degrees Celsius, steel loses roughly half of its structural strength, leading to sudden catastrophic bending and structural collapse without warning. Concrete, on the other hand, suffers from explosive spalling as trapped moisture turns to high-pressure steam, tearing the material apart from the inside. Mass timber columns are structurally engineered with a sacrificial layer of wood. This ensures that even after a prolonged, intense fire event, the inner core remains structurally solid, maintaining its full load-bearing capacity. It is an extraordinary engineering paradox. Timber preserves structural confidence far longer than unprotected industrial metals. Our final engineering milestone moves away from raw structural elements and looks directly at the lifestyle and wallets of premium UK self-builders. Absolute thermal efficiency via off-site automation. Traditional brick and block construction hinders manual labor in unpredictable damp British weather conditions. Achieving a perfectly airtight envelope on an outdoor building site is incredibly difficult, leading to hidden thermal bridges, poor insulation values, and structural cold spots that breed mold. Advanced timber homes completely eliminate human error through computer-aided design and automated CNC production lines. Closed panel wall systems are manufactured entirely inside climate-controlled factories, pre-fitted with high-density wood fiber insulation, vapor barriers, and triple-glazed windows before they ever touch a drop of outdoor air. The result is a house built to strict passive house tolerances. Wood naturally possesses a thermal conductivity value that is roughly 15 times lower than concrete and 400 times lower than steel. By eliminating thermal bridging entirely through precision engineering, these homes can reduce a family's heating bills by up to 90%, turning a luxury architectural choice into a highly sophisticated, money-saving investment for the future. The data doesn't lie. Traditional brick and concrete are no longer the defaults of superior construction. They are increasingly becoming outdated relics of a slower, less efficient era. Modern engineered wood isn't just a sustainable alternative. It is structurally dominant, faster to build with, safer in catastrophic fire events, and vastly superior at regulating internal climate and energy consumption. The future of high-end global architecture isn't made of cold stone and heavy steel. It is grown, engineered, and precision machined. If you had the choice to build your dream home tomorrow, would you choose the automated speed and thermal performance of high-tech mass timber? Or would you stick to traditional brick and mortar out of habit? Let me know your exact reasoning down in the comments below. I read every single one. If you want to stay ahead of the curve on the world's most advanced sustainable building technology and luxury architecture, hit that subscribe button right now. See you in the next deep dive.